In this video, we're going to learn how to graph a logarithmic function and its inverse. So we're going to do quite a few things today. We're going to find the domain of a function, which we've gone over before, how to graph a logarithmic function, which we've also gone over before, and we're going to, from that graph, determine its range and asymptotes, just like before. But on top of that, we're going to learn how to find the inverse, the domain and range of an inverse, and how to graph that inverse, knowing what the original function is. So let's start by graphing f of x is equal to negative natural log of x minus 2. So I'm going to strip away the transformations, give me y is equal to natural log of x. And now you may not have seen ln of x. This is known as a natural log, like I said, and its base is that number e. So I can think of this statement as x is equal to e to the y to help influence what points I'm going to plot on this graph. And I'm going to use the three basic ones, negative 1, 0, and 1. So I need to know what e to the negative 1 is, also known as 1 over e. What's that approximately equal to? E to the 0, which I can already tell that's equal to 1. And e to the first, which is just e, its decimal approximation, so I can see where to graph this on the actual graph. So if I do e to the negative 1 power, I get 0.36. So when x is 0.36, y is negative 1. So 0.36, about a third over, down to negative 1. When x is 1, y is 0. And then when x is e is 1. So at 2.71, 2.7, about right here, x is 1. So I have those 3 points, which I will now draw my curve through, and then shift with the transformations. So my first transformation I'm noticing is for the negative natural log of x. That is a reflection in the y-axis, or sorry, x-axis, since it's on the outside, which reflects it vertically. So all the points will be flipped across this axis, cause it to now be a decreasing type function. So now it's decreasing over time. And then I will apply the minus 2 on the inside of the log, natural log, which caused a shift right 2 units. So now this graph will shift to the right 2 units, which means that its asymptote will also shift to x equals 2. Now I go to the right. And this will be the final form of the graph. So when I shift all the points right, I'm going to put this in red so it's highlighted for you. So I have a point there when it shifts right to. This one shifts right to here. And this one shifts right to, this one shifts right to here. So every point shifted right to from the downward one, giving me this graph. Now that I have it graphed, I forgot to find its domain to start, but to find its domain, I would need to make sure x plus x minus 2 would be greater than 0. So that would be whenever x is greater than 2. So the domain is the set of numbers such that x is greater than 2. Now I can point out its range and the asymptotes. So the range is all real numbers. So it's the set of numbers y such that y is in the real numbers. In the asymptote, I have one vertical asymptote at x equals 2. Now I will go on to find the inverse of this function. The best way to find an inverse is to replace f of x with y, and then just switch x and y and then solve for y. So we'll switch the places of x and y, and it gives me x is equal to negative natural log of y minus 2. Now solving for y, I need to first divide by negative 1, so I'll have negative x is equal to natural log of y minus 2. And then I'll use this equivalent statement up here to rewrite this in an exponential form to get the y out of the logarithm, giving me e to the negative x, because again, the log is equal to its exponents. So it'll be e to the negative x. It's equal to the inside of the logarithm, y minus 2, giving me e to the negative x plus 2 is equal to y. So the inverse function, f inverse of x, is e to the negative x plus 2. Now the domain and range of the inverse function are easy to find, because if we just swapped y and x, if the domain is x and the range is y for the original function, I actually just swapped their domain and range. So now the domain is all numbers x, such that x is in the real numbers, the same as the range of the original function. And the range of this function will be the domain of the original one, so all numbers y, such that y is greater than 2. And then to graph this function, what I will need to do is basically swap the x and y values of all the points I've already graphed. So if I highlight these points, here is about 2.3, comma 1. This one over here is 3, comma 0. And the one over here is about, we add 2 to 2.7, about 4.7, comma negative 1. If I swap the x and y values, then I'll get a point at 1, comma 2.3. 0, comma 3. And then negative 1, comma 4.7. And the asymptote that was vertical asymptote that was at x equals 2 will now be a horizontal asymptote by switching x and y at y equals 2. So basically, you just swap in the x's and the y's to graph the other function. And now you can see this exponential function. It's a decaying function over time right here, which I graphed in blue in comparison to the red. So that function there is my inverse function. The function red was my log function. You'll often notice that these graphs will be symmetrical about the line y equals x. So if you ever want to check to see that you graphed it right, if you graph the line with a y-intercept of 0 and a slope of 1, which I'm lining up right now with my ruler, both graphs should be symmetric about that line if you did it correctly. You'll see here that the red line, the blue line are very symmetric across it. Now let's do another example. We're going to graph this function. We're going to start with y is equal to log base 3 of x, which an equivalent statement would be 3 to the y is equal to x when writing it in its exponential form. we'll use y as -1, 0, and 1. So 3 to the -1, 3 to the 0, and 3 to the 1. 3 to the -1 is 1/3. 3 to the 0 is 1. And 3 to the 1 is 3. So plotting those 3 points, I get 1/3, comma -1. Let me do this in green. 1, comma 0, and then 3, comma 1. And now I have two translations taking place here, which would be shifting left 2, and then +3 would be up 3. So every point's going to go left 2 and up 3, including the asymptote, which if it was at 0 is now going to be at -2. So everything goes left 2 and up 3. So left 2, up 1, 2, 3. Left 2, up 1, 2, 3. Then left 2, up 1, 2. Left 2, up 1, 2, 3. And this would be, since I only had to deal with translations, that's what my graph looks like. And again, I did part B first, but doing part A just means I'm looking for where x plus 2, the inside of the log, is greater than 0, which happens when x is greater than -2. So the domain is all numbers x such that x is greater than -2. The range is all real numbers y. Oop, put an x there on accident. So all numbers y such that y is in those real numbers, so all real numbers. And the vertical asymptote is x equals -2. Now to find its inverse, I'll have y is equal to 3 plus log base 3 of x plus 2. I'll swap x and y, so I'll have x is equal to 3 plus log base 3 of y plus 2, and then I'll solve for y. So subtract 3, so x minus 3 equals log base 3 of y plus 2. Then rewrite that exponential form. The log is equal to the exponent, so 3 to the x minus 3 is equal to y plus 2. Subtract 2, and I'll get my inverse function. So f inverse of x is equal to 3 to the x minus 3 minus 2. Its domain, we forgot to box in the horizontal asymptote there. Its domain, if I'm switching x and y, will be all real numbers. Since the range of the original function is all real numbers, the domain should be all real numbers. So all numbers x such that x is in the real numbers. The range would now be restricted to all things greater than -2. So all numbers y such that y is greater than -2. And now instead of a vertical asymptote, I have a horizontal asymptote at, instead of x, y is equal to -2. So I'm swapping the y for everything with this inverse function. And then to graph it, I'll swap the locations of all the x's and the y's. And I'm also going to graph my horizontal asymptote to start. And swap in all the points. The point right here is at 1, 4. So now it's going to be at 4, 1. Point here is at -1, 3. So now it's going to be at 3, -1. And the point over here is going to be at -2 plus 1/3. So -5/3, 2. So now it's going to be at 2, -5/3. I'll graph this one in blue so they can stick out. But you see here it's flat along the asymptote. Then it curves upward. And it looks like these two graphs eventually even meet up there as well as back here. If I draw out that y equals x line, the reason why it's symmetric about y equals x is because we swapped y and x. You'll see here there are symmetric images across that line. And that's how you graph a logarithmic function and its inverse.